A MEGGER test or insulation resistance test for this two strings of insulators. So we apply a high voltage DC. Here we apply the high voltage here, and to the other side we apply the ground. Now what we will do here, we will have a look to the applied voltage, and we want to watch the current. The current is basically, this is the current and this is the voltage. So notice what will happen to the current the moment we apply the high voltage. So you see the current goes high and then goes down very fast. Can you please repeat this again? Let's also watch the current. Look, when we apply the voltage, the current goes up and then goes down very, very fast. Why this is happening? We'll explain that in the coming video.
So let's answer this question. What is the MEGGER test and why it's used and why the current that we have seen dropped to a very low value in a very, very short period of time? So to start with, what are the applications of the MEGGER test or the insulation resistance test? It's basically to measure the quality of the insulation resistance of different electrical devices for different purposes. And basically, it's a non-destructive test. So the objective here is not pass or fail as a destructive test, but the objective here is to find the value of the insulation resistance, which is usually in hundreds of mega ohm to giga ohm. So one of the applications is to measure the quality of the motor and the generator's insulation of the winding. So we connect it in a certain way to measure the insulation resistance of the motor windings. Also, one of the during the manufacturing of the transformer, we need to dry the active part of the transformer. So usually we put the active part, which is composed of the winding and the core, inside an oven, and we dry it for several hours to make sure that there is no moisture absorbed by the insulation paper. How to ensure that the dryness was effective? We measure the MEGGER test of the insulation of the transformer winding. Also, cables as well. You apply or you use the MEGGER test to see the quality of the insulation of cables. So in all these applications, basically what we do, we apply high voltage DC and we measure either the current or the device will give you directly the resistance using Ohm's law. The resistance will be actually the voltage divided by the current. Now the question is why we have this drop in the current. We might not even notice, but this is a capture from the video that you just saw. So when we start the test, the voltage was 0.08 kilovolt. I'm just started to increase the voltage. The current was 0.56 microamps. Then when I reached that voltage level, the current was already 0.02 microamps. Why that drop in the leakage or in the current and happens very, very fast? So basically, the current that we measure using the MEGGER test, it has three components. The first component, it's the capacitive component, because the way we look to the insulation of any system is basically composed of a capacitor in parallel with a resistance. So that is the circuit model of an insulation system. So this is the capacitance and this is your R. So when we apply our DC voltage here, the capacitor will be the moment you close the switch, you start the DC, change into a short circuit. This is how the capacitor reacts to the DC, and then eventually it becomes an open circuit. So this is why when you look here to the capacitive charging current, you start here at the beginning at a very high current, and then the current drops significantly in a very fraction of a second, drops to a very, very small value. This is when the charging happens, when the two electrodes and between them the insulation, which will act like a capacitor, when you fully charge that capacitor, then the current drops to 0. So that is the first current that we deal with. The second current is the absorption current, sometimes called the polarization current. That current basically it represents the additional energy necessary to reorient the dipoles of the capacitor. And that current also starts at a high value, but the way it drops, it is much slower than the way the capacitive current it drops. Okay, so now we have two components related to the capacitive component of the insulation system, and both of these currents are actually dropping. The last current basically is the conduction or the leakage current, and that is the current that represent the quality of the insulation. And the current starts at 0 and then increases and then stabilizes. That is the current basically that we actually use to measure the IR. And this is why when you do the MEGGER test, you have to wait for around 1 minute until both the capacitive current and the absorption current goes to 0, and you will be just measuring the insulation resistance due to the conduction or the leakage